So in today's lecture we are going to discuss a JEE advanced question on the fluid mechanics on the pressure variation. So here I have taken this question where there is a container. This container is moving with some acceleration on an inclined plane. Let's suppose that acceleration is given as a, and the gravity is acting in downward direction g, and the angle of inclination is 45 degree. Now in the question they are asking a quantity which is beta. Beta is P1 minus P2 divided by rho GD, where rho is the density, D is the diameter of this tube. So how much will be beta? It is a multiple correct question, multiple options. So let us look in the first option. In the first option they have said that the beta, which is P1 minus P2 divided by rho GD, is 0 when the A is g by root 2. So for this we need to go into the concept of the accelerated container. If we accelerate a container, what would happen? Let's suppose there is a container, and if I accelerate this container with some acceleration a in the horizontal direction, then I know that the surface will become like this, right? And this surface will be perpendicular to the effective net acceleration, and this effective net acceleration is given by the vector addition of the acceleration due to gravity, and this acceleration of the container is a, which will the pseudo force of this will create the pressure variation in the opposite direction. So you can take the a in the opposite direction, and then you can do the vector addition, and then you can say a net is square root of a square plus g square. Okay, that was the concept, and the surface will be perpendicular to that, and these surface, any line parallel to the surface is going to be called as the equipressure line, will have the equal pressure on that. Why I'm teaching this concept? It's because look, if beta is 0, it means that the pressure difference between this point and this point is 0. Is it not that these 2 points are situated on a equipressure line? It means the line passing through these 2 points must be a equipressure line, right? It means that the surface of this liquid must be like this, parallel to the inclined plane, right? So can I say that the net acceleration of the fluid particles, okay, or that we will use for the calculation of the pressure, must be perpendicular to this? All right, that is how we are going to reach to this answer. It means I can say that the net acceleration must be perpendicular to this inclined plane right now in this situation. Okay, so we have this inclined plane like this, and there is a gravity g acting in the downward direction, and then there is a acceleration a acting. Now a is not perpendicular to g, it is at some angle, and this is the perpendicular to of inclined plane, and we know that perpendicular of inclined plane and gravity will form the same angle of inclination, 45 degree. So that is why I can break this acceleration of gravity into the two components. One component is perpendicular to the inclined surface, which is a equals to g cos 45, or otherwise g by root 2, and the another component is going to be a equals to g sin 45, which is also g by root 2, right? These are the components. Let me call it as a1, and this is a2. Now there is the acceleration a, which is the acceleration of container, and this opposite of that is going to create the pressure variation. Now if this acceleration and this acceleration becomes equal, then there will not be any pressure variation in this direction, and the net acceleration will become perpendicular to this, and that is why this will become a equipressure line. Okay, it means a should be equal to g by root 2 if we want to have this surface or equipressure line parallel to the inclined plane. So that is why first option is correct, and naturally when the first option is correct, so then the second option is incorrect. Now the third option says that the beta is this much when the A is G by 2. Okay, if A is G by 2, then look, let us again calculate the net acceleration. So if I take gravity's component, so gravity's component is G by root 2 like this and G by root 2 like this. Okay, and this side we have acceleration A equals to G by 2. Okay, my handwriting is not that much good, so you can understand this. All right, so A is G by 2. Okay, so look here, who is going to create the pressure variation? A perpendicular acceleration or a acceleration which is in that line. A acceleration which is in that line, that is going to create the pressure variation. All right, so that is why let us calculate the net acceleration in that direction. Net acceleration in that direction, will it be G by root 2 minus G by 2, okay, which I can write down as G by 2 if I take denominator, so then that is root 2 minus 1. All right, yeah, so this is the net acceleration, and that is why the pressure variation is going to be in that direction, rho A net multiplied by distance, and distance will be the diameter of this tube D. So del P is going to be rho G by 2 root 2 minus 1 multiplied by D. So then what is the beta? Beta was given as delta P divided by rho GD. So rho GD will cancel out, so then it is root 2 minus 1 divided by 2. So beta value is this when the A is G by 2. Okay, so the option C is also correct. All right, so hope you understood this video. Now you can also look at the other videos, and if you want to understand the concept, you can look at the concept videos. Okay, thank you very much.